Good morning friends. Today I am going to explain about aberrations. Aberrations means defects of lens. Defect of lens means whenever a light is passes through the convex or concave lenses, then the image formed by the lens will have a some defect. Means sometimes it is blurred, sometimes the size will be different, sometimes the shape will be different. So those defects are calculated by the simple equations, is known as the aberrations. And I have given a definition for the aberration, that is the deviation from the actual size, shape and position of an image as calculated by simple equations are called aberrations or defects produced by the lens. Here there are 6 types of aberrations are there, that is chromatic aberration, spherical aberration, coma aberration, astigmatic aberration, distortion aberration, curvature aberration. Today we are going to talk about what is chromatic aberration and how many types of chromatic aberration. Okay, so here the chromatic aberration means if the light is not monochromatic. Not monochromatic means, what is monochromatic means? Single wavelength. Okay, so remember this one. If monochromatic means that is a single wavelength. Okay, if the light consists only one wavelength, that time what will be the image of the object? So here what is monochromatic means? Single wavelength. If the light is not monochromatic, okay, so then the image becomes as chromatic aberration. The chromatic aberration is due to the fact that the refractive index is varies with color. Okay, so we all of you know what is refractive index. Refractive index is nothing but that is the ratio between the sin I by sin R. Okay, so this ratio sin I by sin R will be different for the different colors. Okay, it means that is whenever a light is passes through the convex lens, so that time the image formed by the lens will be blurred, or that is because of the refractive index. Here let us suppose this is a parallel beam of white light. Okay, it means that is if the light is not monochromatic, means the light is not a single wavelength, it's a having a achromatic light, means that is having a 7 colors, then the image becomes the chromatic aberration. The chromatic aberration is due to the fact that the refractive index is varies with the color. It means that is the angle of incidence by angle of refraction is nothing but a refractive index, and this refractive index is different for the different colors. Okay, so here I have given a little bit explanation. When a parallel beam of white light is refracted, okay, so here the parallel beam of white light is refracted through a lens, then the violet rays meets first and the red rays meets further point. Here violet rays meets first and the red meets further point. So I shown in this figure. Here this is because the refractive index of violet color is greater than the refractive index of red color. Okay, here this refractive index value mu v is greater than the mu r. So mu v is greater than the mu r, so that's why those meets first, due to which the focal length of this one is less than the focal length of violet color. Okay, so is greater than the refractive index of red color, and hence the image, the focal length of the violet color is less than the, what is focal length? Focal length means nothing but it's a distance between the lens to the focusing point. Okay, here distance between the lens to the focusing point is called the focal length of red colors. Fr means focal length of red and Fv means focal length of violet. Okay, and this focusing of different colors will be formed on different points due to the refractive index. Okay, if the screen is placed, now if you imagine, let us suppose a screen is placed at this position. Okay, then the center of the image will be violet and the outside surface will be red. And if the screen is placed at this position, then the center of the image will be red and outer surface will be violet. If the screen is moved in between FV and FR, then we will get a blurred image. Okay, So that particular defect is known as the chromatic aberration. So I wrote, if the screen is placed at Fe, then the center of the image would be violet. If the while the outer surface will be red. If the screen is placed at Fr, then the center of the image would be red, and while the outer surface will be violet. For all coefficients between Fe and Fr, the image is blurred. Okay, the image is not clear. Thus, the image of a white object formed by a lens is colored blurred. Okay, so this defect of the image is known as the chromatic aberration. Okay, so chromatic aberration takes place if we are not taking the monochromatic light. So it means if the light is consists of all the colors, so that time the light passes after passing through the convex lens, converging at different points on the axis. Okay, when it is converging on the different points means then the image of the object will be blurred. Okay, so that is known as the chromatic aberration. And there are two types of chromatic aberration. Those are longitudinal chromatic aberration and lateral chromatic aberration. So longitudinal chromatic aberration is nothing but it's a distance between the FV and FR. Okay, so just for the explanation I wrote here, longitudinal chromatic aberration, the formation of an image of different colors in different position. Just now I told you the image is formed at different position, okay, on the axis, is known as the longitudinal or axial chromatic aberration. Okay, for this purpose we have taken a point object. Okay, remember here the object is the point object. Let a point object O is placed on the axis of a lens as shown in the figure. As we know that the refractive index of mu V is greater than the refractive index of mu R. Okay, so that's why the violet and red images of the object are formed on the axis at FV and FR. Okay, that is F is the focal length of violet color, FR is the focal length of red. Okay, the distance between the FV and FR is represents the chromatic aberration or longitudinal chromatic aberration. Okay, the difference between FR and FV. In case of convex lens, just I wrote a note for remembering point. In case of convex lens, the longitudinal chromatic aberration is positive, and in case of concave lens, it is negative. Okay. Now, second type is lateral chromatic aberration. When the images of different colors are formed at different sizes, then the defect is called as lateral chromatic aberration. Okay. Here in the last case for the longitudinal chromatic aberration, we have taken only a point object. Okay, now because of the point object, on the axis we got a different position, the image will be blurred on the axis at different position. Okay, this is known as the longitudinal chromatic aberration. For the lateral chromatic aberration, we have to consider a object. It's a point object we have to consider. It's not a point object, it's a object having some size. Okay, so that time the image formed by this lens will have a different size. Just like I will show you here. AB is the object, then the light rays are white object, particularly here white object, and when the light rays passes through this object AB through the convex lens, then the image formed by the lens will have a different sizes. That is AV size, AVBV size is less than the AR BR. Okay, image size. So the difference between those two images is nothing but a lateral chromatic aberration. Okay, so this is lateral chromatic aberration is depends upon the sizes, whereas the longitudinal chromatic aberration just only a point image is formed there. Here, when the image of different colors are formed at different sizes, then the defect is called the lateral chromatic aberration. This is due to the fact that the magnification of white object is different for the different color. So what is magnification? That is nothing but a size of the image by size of the object. So size of the image by size of the object, that is the magnification is different for the for the violet, for the red, for the yellow, it is different. So due to that you will get a different sizes images. So that defect is known as the lateral chromatic aberration. Okay, thank you. For more videos, subscribe my channel Physics.